Hello, my name is Juneal.
And I'm Ethan.
And I'm Stefan. And we're missing our fourth member, Dylan. And in our final year of mechanical engineering, we developed a haptic feedback device for finger rehabilitation.
Our capstone is called a haptic system for finger feedback because the device we've developed uses haptic technology to apply very precise forces to a user's fingers to allow them to perform rehabilitation on any hand or finger injuries that they might have.
A haptic system is a form of technology that provides tactile feedback in the form of physical interactions, such as vibrations, forces, motions. An example is the vibrations given to the user's fingertips when they're typing on the keyboard of their phone.
So a haptic system, the heart of it is a capstone drive mechanism. Essentially what that is a way of applying gear ratio to a motor without having any backlash friction when you backdrive the mechanism. And that's needed because we want to have a completely frictionless and inertialess system for the user when their hand is in it to make it feel like as if the device isn't there.
In a haptic system, inertia refers to how much the device resists moving when you interact with it. Inertia is a challenge in current devices, as minimizing inertia is critical in creating a realistic haptic feedback system.
The way our device works is essentially the user would put their hand in, they would wiggle around their fingers until they reached a certain point that we wanted to restrict their movement. At that point, the encoders would be able to sense that position. They would send the message to the Arduino, which we're using to control the device, and then that would send a message to our motors to apply a force in the opposite direction to restrict that.
Our code is capturing the encoder pulses, or how many times that the motor shaft is rotating. And so from there, we are able to perform some computations to determine from the rotations how far your fingers have actually moved. And through that, we are able to determine the corresponding current that would be applied to the motors.
I would say hospitals or patients could use this data for tracking the user's progress on how much force they're actually able to apply with each finger and see if they're regaining their strength and their mobility. And it just gives us a way of accurately capturing that kind of data.
What's being recorded from the hand movements is the position and momentum of the individual's fingertips using the encoders.
Devices like this kind of exist already. They're used in hospitals all the time for patients with these kinds of hand problems. But the big issue with them is, one, they're huge, they're too clunky, and they're insanely expensive. They're somewhere in the range of millions. So usually a hospital will just have one of these devices, which is not that great. The issue is there's a huge barrier for entry if somebody has problems and wants to get rehab on their fingers. So we made this device. The goal was to make it a lot cheaper and portable so that they could buy one themselves and have it in their homes.
So this device is normally for people with hand injuries and or nerve damage, and so they have limited strength and mobility in their fingers. So the point of the device is to apply a very fine and precise force profile onto their fingers that would mimic them doing a regular action like grabbing a ball or something like that. So we can apply that similar force profile to their fingers, but very low magnitudes, and have them work their way up over and over again until they can build their strength back up. And that's how it's basically, we perform the rehabilitation on their fingers and get them back to 100% again.
The encoders that are included into the device are used to track the position and the momentum of the user's fingers while they're operating the device. That in turn decides what force is to be applied and at what specific time.
The encoders are measuring the rotation of the motor shaft, which in turn allows us to tell the exact position and momentum of the user's finger. That tells us the time and the magnitude of the force that we want to apply to make it feel like there is something there that's not actually there.
So the more that the patient is moving their hands, the more force would be applied. We would increase the current that is applied to the motors in order to simulate a larger force.
The prompt for what this project was going to be about, it was very vague, and it was just we're making a haptic feedback device. That's it. And so what we were envisioning is a kind of a glove device you could put on your hand, and we would be able to simulate a force, it would pull back on your fingers. So you could simulate that we're grabbing something, and we can have it communicate to an external robotic hand and have that move as well and feel what it was grabbing. That could be a future application for this kind of technology, but that's what we were envisioning building. We didn't end up doing that because that's kind of like crazy scope. So we ended up with what we have. But yeah, it still turned out great.
Our capstone supervisor, Dr. Karush, is actually talking to some doctors at a hospital. And one of the issues that they found is that a lot of these rehabilitation devices that use haptic feedback are really expensive or are not as accessible to people that need it. They're usually a lot larger in size and cost a lot. And so the patient that needs this type of rehabilitation would have to go to the hospitals. And we wanted to make a device that was significantly cheaper and that the patient would be able to bring at home and use at home or whenever they would like to use them.
Coming from different backgrounds, myself and Juneal and our other fourth member, Dylan, we're all mechatronics. Ethan is mechanical. So from our side, we have a bit more experience in like computer and electrical engineering topics. So we kind of took that side of the project. So Dylan specifically, he was our project lead. He was kind of like the project manager, making sure we were on time. We were getting the parts that we needed and everything was, he oversaw everything kind of. Myself, I kind of handled the main design of the device. I made all the CAD for the device, all the mechanisms and how everything would fit together. I kind of did all the design work for that.
I was more in charge of the actual manufacturing part of the device. I brought Stefan's amazing design to life alongside Dylan. And also at this point, we'd like to thank Matthew for letting us use all his tools in the shop and all that, of course. But yeah.
And then a large portion of what I did was the software and everything that goes behind the electronics, just making sure that the program works, that the encoders are able to communicate with our electronics and the electronics are able to communicate back to the motors to ensure that we have the right amount of force being applied at the right time.
The language that we used to program our device was C programming language, where we programmed in the software Arduino IDE in order to control the Arduinos that we were using for our device.
I would say for this project specifically, probably mechanics of machines or control systems.
For me, what the course that helped the most with this project was advanced manufacturing.
For me, the course that helped the most was microprocessor systems.
No, there's a lot. There's a lot we would change, definitely. I think the biggest issue with our design right now is the encoders. A large amount of issue we were experiencing was our motor coils. The thing that the capstan cable wraps around, it was not, we drilled holes into them. They were not perfectly concentric, so as we rotated it, it kind of was a little wonky and that was causing a lot of friction as it was rubbing against the encoder. I think looking back, we would probably purchase motors with encoders already attached. That way we wouldn't have to mount them on the other side of this shaft, and that would minimize a lot of the friction that we had. There was a lot of other issues. What you guys think?
Another large contributor to our problems though was specifically time. I think if we had an entire year rather than just one semester, who knows how good our project really would have turned out. But for the given time, we did what we think is best.
I was doing a co-op right after my third year at a company called MDA. I've been given a full-time offer, so I've just returned there. I've been working there, and I will be working there. They're it's a space robotics company. They work on the Canadarm, so it's pretty cool.
Throughout my undergrad, one of the big things that I've done was contribute to Orientation Week. So throughout my time here at TMU, I was an orientation leader, helping the new incoming students facilitate their transition from high school to university. So as I'm leaving and graduating, one of the final things I'll be doing is working on the orientation committee.
As a graduate engineer,